Okay, so today we're going to prove that between any two real numbers, there exists a rational number. So I'm going to show what we want to prove, and I'll explain a little bit. So we want to show that x is less than m divided by n, which is less than y, where x and y are our arbitrary real numbers, and m divided by n is our rational number, since m and n are integers, and any rational number can be represented by an integer divided by an integer. So let's start off with letting x be less than y, where x and y are integers. Now we can subtract both sides of the inequality by x, yielding 0 being less than y minus x. In other words, y minus x is positive. Now I say this because the Archimedean property of the real numbers tells us that if we have any two positive real numbers, then there exists a natural number where if you multiply one of the real numbers by that natural number, it will be greater than the other real number. So notice we have y minus x is greater than 0, and 1 is greater than 0. See, we can start using this Archimedean property. So by the Archimedean property, there exists some natural number n such that n times y minus x is greater than 1. Now, we can start doing some algebra, distribute the n, yielding ny minus nx is greater than 1. Now notice, ny and nx are both real numbers, since the real numbers are closed under multiplication. So this inequality is telling us that that the difference between these two real numbers is greater than 1. Now, we know that the integers are spaced 1 apart. Thus, if these two real numbers, if the difference between them is greater than 1, then there exists some integer between these real numbers, which is what we have here. So thus, there exists an m in the integers such that nx, some real number, is less than m, our integer, which is less than ny, another real number. So, since n is a natural number greater than 0, we can multiply the inequality by n, giving us x is less than m over n, which is less than y. Now, that looks like exactly what we wanted to prove. We have x and y as our reals, and m over n being our rational, and it's in between two real numbers, which were just arbitrary and randomly chosen. Thus, we have proved what we wanted to prove.